So the roundtable portion of the theater is finished, and we start our individual presentations. And we are starting with Rene Gantier, who is the R&D Director of Biopharma Applications at Pall Life Sciences. Let me get started here, and let me introduce Rene. Again, Gantier, he is the R&D Director of Biopharma Applications at Pall Life Sciences. His presentation, Manufacturing Flexibility at the Heart of Continuous Bioprocessing. Rene.
Thank you for the introduction. Hello, everybody. So let's talk about continuous processing. I heard that the previous session was mentioning that, but let's go a bit deeper into this. And let's go through the outline of my presentation. First, the first thing I will tell you about the roadmap as we see it at Pall to go from the batch process to a flexible, disposable, and continuous processing. And then I will tell you about some technologies that we already have at Pall that enables the jump from batch to continuous. The first one is the BioSMB technique, continuous chromatography, that Pall acquired not long ago. And the second one is the single-pass TFF technique with the inline concentration as a continuous technique as well. And then after that, we'll be able to show you what we can propose already as a platform or a solution as an hybrid between batch and continuous processing to be able to think about the future and being able to go to fully continuous in the near future. But as we're talking about continuous processing, we need to know why people are so interested in going to continuous processing. And if you look at the major industry, they are already moving towards continuous, or already have moved to continuous processing. And the first argument is, of course, money. When you go from batch to continuous, you save money. You save money on the capital utilization. You improve your capital utilization. You reduce your operational expenses, so you save money. But there's also another obvious argument, is that you have more control on your process. So you really improve the safety of your process. You have less operators, so you reduce the risk of anything happening in your process. And you improve also the control on your product quality. So those are two major arguments to move from batch to continuous processing. And in the biopharm industry, this is where we are now. This is basically how a batch process looks like. From the media preparation to the cell culture and all the different steps, going to the final formulation, you have a lot of steps. That requires pretty big equipment at manufacturing scale. And all those steps are conducted one after the other. So it takes quite a long time to do that. So big equipment, long time to process, many steps. On the other hand, if we foresee what should be a fully continuous process, this is how it would look like. Less steps, you reduce the number of steps in your process, and you are able, as you implement the continuous techniques, to be able to reduce the size of the equipment, going to more intensified processing, and also reducing the consumable part of your process. And if you look at the time to process, there's a significant saving in terms of time also in your process. So less steps, reduce capex, reduce consumable expenses, and less time. But this is what we want. This is where we want to go, but we're not here now. But what we can do already is to try to implement some continuous step into a batch process. We can do this right now. And for instance, here on that slide, you can imagine that we would implement a continuous chromatography or continuous chromatography steps into a batch process. And in that case, if you look at the size of the equipment, the time to process, you are already saving time. And I will show you that we can do that already now. But I told you about the roadmap as we see it at Pall, and this is the way we see it. The first step you need to go from the batch to continuous would be to go to single-use, having single-use facilities, and then being able to have a full automation of those single-use facilities. After that, you are able to implement some continuous steps into a batch process, having some hybrid batch continuous processing, to be able to go to the final step, which is the fully continuous process. So let's have a look at the two first steps, the single-use and the automation. We consider that we already have this. If you look at on the upstream side, we have solutions at Pall where you can do your cell culture in a fully automated and disposable mode. Those are two examples of single-use bioreactors that we have. They are fully automated, fully disposable. You can process at manufacturing scale for the cell culture on a disposable and automated mode. On the downstream side, that's almost the case as well. If you look at all the different steps that you want to implement in the downstream, we can propose solutions, automated and disposable, for most of the steps in the downstream side. If you look at the depth filtration, we can propose you some single-use automated steps. The same for the virus filtration, the virus inactivation, everything linked to the media preparation and buffer preparation, mixing and adjusting pH, even chromatography with the membrane chromatography. We already can provide you some solutions, disposable and automated. So disposable, automated upstream, yes. Downstream, yes as well. So we can consider that those two steps, it's done. So we can focus now on to the next step, which is trying to implement continuous step within a batch process to be able to go to the final step, which is the continuous. And if we look at, again, those process, the hybrid batch continuous or the fully continuous process, let's have a look where we can implement continuous first. And let's try to find some enabling technologies already for continuous chromatography. And at Pall, we do have now a technique which is called BioSMB as a disposable continuous chromatography technique that Pall acquired not long ago, and you can see the machine at our booth. And this technique really is a transformational change from batch to continuous, as it really enhances the process efficiency. It is a continuous step, so you can, everything we said about the benefits of the continuous processing, you will have it implementing a continuous chromatography step with this machine, saving time, saving chromatography resin consumption, buffer consumption, etc. It enables all continuous chromatography features, meaning you can implement that as a fully single-use and integrated process, but you can also implement this as an isolated continuous step within a batch process. And this is what we are doing now. Of course, you can run whatever type of chromatography mode that you want. It could be affinity, ion exchange, mixed mode, whatever chromatography mode, and on whatever type of media. It's not restricted to resins. It could be membrane adsorbers. It could be whatever you want. You can implement continuous chromatography with this technique. It relies on a patented technology that enables really the continuous and disposable chromatography technique. So it relies on the integrated valve cassette that you see here on the right-hand side, where so this cassette is really designed for single-use and or disposable. So you have a fully disposable flow path with this cassette. It can handle up to 16 column position, thanks to a large number of valves that are included into this cassette. You see those valves here. Those are diaphragm valves. And it can be, of course, used for chromatography, but you can imagine using that valve cassette for whatever fluid control application. So it's really a flexible solution and a simple and scalable solution. Here is a picture of how it looks like in activity, I would say. But again, you can see the machine at our booth. So you plug the disposable cassette onto the machine here. That is where all the valving events are occurring. And you need a lot of valve events to make a process continuous for chromatography. You plug next to the cassette some pre-packed column, multiple column, so that you can have a continuous load on your system. We prefer using pre-packed column as you have a better control on the packing efficiency so that you really get the most efficient BioSMB run as well. And on the right-hand side, you see those disposable sensors, so you really you really can dispose those sensors. Those are pre-calibrated and really easy to use. So this is how it looks like. Those are the application range that you can cover. It's not only a technique that you will implement at process development scale. You can go to several thousand liters of bioreactor using that technique. And as you cover that wide range of bioreactor volume, you are able to use a broad range of pre-packed column diameter as well, from 10 up to 45 centimeter ID column. So pretty broad range of application. I told you that you can save money when you implement a continuous step in your process, and this is an example on really a quantified example. For this given scenario, imagine that you have a clinical campaign where you would have 2,000 liter bioreactors at 5 grams per liter for your product, and you would run 5 batches. This is really the typical numbers that you can expect when you compare the batch to the BioSMB run. You can save more than half the money you spend in your process in a batch mode when you implement a continuous mode. And if you look more in detail, where the money is going is mostly on the cost of the resin. If you think about the protein A step, the protein A resin is very expensive. And as you reduce drastically the volume of this resin used, you save a lot of money. So, going back to our process, we have a solution now for the continuous chromatography steps. So we are able already to plug into a batch process a continuous chromatography step. But you see that there are still a lot of room for continuous techniques into the full process. And especially looking at the filtration, this would require, again, some enabling technologies. And we do have such a technique for continuous filtration. And this is the single-pass tangential flow filtration with the Cadence inline concentrator. So this is a TFF technique, but it's an inline and continuous technique. It relies on the patented single-pass TFF technology. And those inline concentrators, as you see pictures here, they were really designed for ease of use. So it's a plug-and-play design. They are pre-assembled, pre-flush modules, so you just have to plug it into your process. And you don't have holder. You don't need a holder to keep the cassette all together. In terms of application, you can use this continuous technique and inline technique for high concentration application, but you can also, of course, use that for volume reduction application. And on this slide, you see kind of flavor of what you can do with this technique, where you can plug those inline modules into your process. So it could be right after the cell culture as a post-harvest volume reduction. It could be just in line with your chromatography column to be able to reduce your volume load and save time on the load time. You can, of course, use this in any in-process volume reduction step. And obviously, you can still do your final concentration as TFF is used to. So a very really versatile type of application for this inline concentrator. And so we have those two continuous techniques. So why not connecting them all together? And imagining that we can have a continuous process from the clarified cell culture down to the purified product after chromatography. So if you plug an ILC just before the BioSMB, what it looks like, what you can get from that. And actually we did the experiment, and here is the data. If you compare what you have in terms of batch, BioSMB only, or connecting the inline concentrator with the BioSMB, you can see easily that you really increase drastically your specific productivity. The amount of product that you process in a given amount of time, it's multiplied by 10 compared to the batch. So it's really a significant increase. And if you look at the BioSMB only, you see that you really have you really have a synergy between those two techniques to get the best process you can imagine. Here you see the data. We were really able to get a very stable process for more than 20 hours. The productivity of the process were really stabilized, and the quality of the product also stable. So stable, high process productivity, connecting those two techniques in a continuous mode. Of course, you can expect that you will save money as you increase the productivity. You will save money in your process. And this is especially the case if you have product titers that are pretty low. Imagine that you have a cell culture process where it's not fully optimized, between 0.1 and 1 gram per liter, and you don't have to worry about improving your cell culture performance. With that connection, the ILC that increase the product concentration and then the BioSMB that do the rest for the continuous chromatography, you can save a lot of money in your process connecting those two steps, so that you can reduce the time to market. No need to improve your cell culture performance. So this is just one example of what you can do if you start connecting the dots, having techniques continuous, and you put them all together. That is really a good story to tell, and we'll continue doing that. But now we can already propose you this type of process where you will be able to mix some continuous step with some batch steps. For the bioreactor and the depth filtration, we don't have a continuous process for now, but we have the single use and the automation. But then you can imagine in a continuous mode having the Cadence ILC followed by the BioSMB technique for the chromatography. Then again some batch mode with the virus inactivation, going back to a continuous step with the BioSMB, etc., then to the sterile filtration. So this is what we propose for now. It's fully single use, automated, hybrid batch continuous process. We can deliver this right now. And of course, we are in R&D, we are working further on further solutions for fully continuous process, but this is what we are already providing you. So thank you for your attention, and I will be ready to take any question. How about bioburden from bioreactor? Bioburden control. Well, imagine that for the continuous process, you are able to, the filtration step, the direct flow filtration is not so difficult to imagine in a continuous mode. So you can implement, before the chromatography, after the chromatography, having some bioburden control filters in your process. So you will have a full control at any step in your process on the bioburden. Imagine that it's a fully continuous process. You do not have the product getting out at any moment, so you do not have anything going in neither. But for now, having hybrid solution, you can implement some plugging some filters to be able to control your bioburden. Any other question? All right. Thank you very much.